Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. We've got another great topic for you today. Here it is. Add a J1939 encoder to a Horner PLC. You'll find J1939 networking in mobile applications all over the place. And not just mobile. Any application where there's a diesel engine or even an internal combustion engine, you'll likely find J1939. So that could mean agriculture. It could mean big compressors. It could mean shipboard applications. And having a PLC that can sit on the same network with all that J1939 data and accept that data and use it for your application, that can be really handy. So today we're going to talk about the Horner PLCs and their J1939 capabilities. Okay, without further ado, let's break down today's topic. Okay, to help me with the topic today, I have a special guest from Wachendorff, a German company that specializes in encoders and in J1939. So we'll welcome them in soon. We're going to cover the Horner all-in-ones, which of course, for those of you not familiar, an all-in-one is a PLC with a built-in HMI. And we're specifically going to talk about the Horner all-in-ones that feature J1939 functionality. We'll do a review of J1939, what it is, and what are some sample applications for J1939. And then at some point, I'm going to show you how to connect and configure a Wachendorff J1939 encoder to a Horner all-in-one. Okay, so today, as I mentioned earlier, we have a very special guest who's going to join me to discuss J1939, and that is Thomas Bako from Wachendorff. So let's go ahead and bring in Tom right now. How are we doing today, Tom?
Hi, Chuck. Thanks for having me today. Glad to be here.
Awesome. Yeah, well, we appreciate your expertise. And J1939 is a topic that I've wanted to cover a little more than we have in the past, and I thought it was a great opportunity to bring you in. All right, why don't you tell us a little bit about yourself?
So I'm the business development manager for USA for Wachendorff Automation. I've been with the company for about 8 months, but I've been in the industry for over 20 years. So I have pretty extensive industrial automation, sensor, process control background. That's a little bit about me. I head up, the business activities for the U.S. subsidiary of Wachendorff Automation. They're headquartered in Geisenheim, Germany, which is southwest of Frankfurt by about 30 minutes.
Awesome. And where are you located in the U.S. from your U.S. office standpoint?
I'm in the Chicago area. We do have an office in downtown Chicago. We do have two separate websites, Wachendorff Automation USA and also Wachendorff GmbH.
Awesome. So it looks like you're a pretty nice sized company. I see there about 150 employees.
That's correct. We do about 30 million in turnover. We have partners spread around the world, and then we have three different subsidiaries.
Nice.
Which I'll talk about later.
Okay. And these are some of the things these are some of the things you specialize in, it looks like.
So I mentioned a moment ago that we have three subsidiaries. The headquarters is in Germany, and then as you know now, I'm part of Wachendorff Automation USA Inc. And we also have a subsidiary in China, which serves the Asian market. We have partners spread around the world. We're involved in over 6 continents. We have several thousand solutions implemented. We do customizations as well. So we have over 900 variants of products we've developed for our customers.
Nice. And it looks like your product portfolio includes different encoders and some other things. What do you have here?
Yes, that's correct. So, we manufacture incremental encoders, absolute. We also take that technology and implement it into things like length measurement systems. There you can see depicted an arm with a wheel, draw wire technology, digital shaft copying. So applicable in many different market segments, for which I'll talk about again in some later slides. But and then some accessories that go along with them, coupling, torque supports, shaft adapters, different types of wheels,
Sure.
and cabling.
Yeah, it makes a lot of sense. And of course, today we're primarily going to be focusing on J1939. And of course, at the very end, we'll have an opportunity for you to kind of talk about some of the other industries that you're involved in. All right, thanks for that overview. That's fantastic. So Tom is going to be joining us later in the program as we go through the details of J1939. What is J1939? What are some of the applications where J1939 is used? He's got some great information for us on that, and we'll bring Tom back here in a little bit. We'll talk to you soon, Tom.
Thanks, Chuck.
Okay, now let's talk about the Horner products that support J1939 communications. Now, what Horner specializes in are all-in-one controllers. Now, all-in-one controllers are the same as a PLC, but they include extra components built in. Okay, so you've got the logic CPU and the I/O system of a PLC, but you also have a built-in HMI. You also have a bunch of industrial Ethernet protocols built in, along with field bus support in the form of CAN. And several of the models on the CAN port support J1939. Now you program a Horner all-in-one just like a PLC, okay, with an all-in-one software package called Cscape 10, which is free. All right. Now, if you're wondering what I/O is available for the all-in-one controllers, well, there are a variety of different options. Okay. So with the two most popular series that support J1939, and we'll show you the size of those screens and those sorts of things coming up, you have a variety of different built-in I/O options, ranging from no built-in I/O at all, from say 22 to 42 I/O points, with plenty of digital and analog options supporting a variety of different signal types. So you've got a wide variety of I/O that you can order with your Horner all-in-one. Now, in terms of the specific models that support J1939, let's go through that now. So the least expensive units that support J1939, or the entry level, if you will, would be the XLT and XLE. Now, these are a couple of old school units. They're very rugged. You can put them anywhere outdoors. They have good temperature range. They have sunlight viewable screens, even though they're monochrome. And they're an excellent option for an application where you want to stick a PLC out in the elements and just forget about it, and the screen isn't a very important part of the application. The XLE and XLT are an excellent option in those cases. So for those units, you would just order one of those products with the J1939 factory option, and you're good to go. Now with the Prime series, shown there at the bottom, there's two different options with the Prime series. Now you can see there's actually several different screen sizes, but when it comes to J1939, there's a couple different ways that you can get that functionality. First of all, if you're using the XL4 Prime, XL6 Prime, or XLW Prime, those units will support J1939 if you order the factory option. If you're using the XL7 Prime, the XL15 Prime, and the XL10 Prime, those units support J1939 out of the box through a second CAN port that's built right into the unit. And then with our Canvas series, which is our top of the line series, it's our newest series, all those units in the Canvas, no matter what model you choose, they all feature native J1939 support. So with Horner, regardless of what screen size you're thinking about, what I/O combination you're thinking about, you've got plenty of J1939 options. Okay, so now we're ready to talk in more detail about J1939. What is J1939? What are some of the applications in which J1939 is used? So to do that, let's bring Tom back in. So Tom, are you ready to talk J1939?
Let's do it.
All right, sounds good. Take it away.
All right, so what is J1939? In short, it's a standard developed by SAE. It defines how the ECUs communicate via a CAN bus, and primarily with heavy duty vehicles.
Yeah, let me interject a little bit here. Just, we'll kind of have this discussion together. So for those who aren't familiar, ECUs stand for Engine Control Unit. So really, J1939 is applicable everywhere there's an engine, whether we're talking internal combustion or whether we're talking diesel. So continue on.
That's right. And, most vehicles today, use the CAN network along with the ECU for communication. You'll find it in a variety of vehicle applications.
Yeah, and basically, it's I know in automobiles, it's pretty much been mandated since about 1996 that they have to use J1939. So it's not new. It's a protocol that's been around a long time, and it's in heavy use.
Correct. So, there's a few important things to understand. That the CAN protocol only provides a basis for this communication. In most heavy duty vehicles, the language is the SAE J1939 standard defined by the Society of Automotive Engineers. And in, more technical terms, it provides a higher layer protocol, based on the CAN network as the physical layer. If you understand networking, there's different layers in the communication packet.
Sure, absolutely. So just like CAN Open is a higher layer protocol that's used in factory automation primarily, but a lot of other applications as well. J1939 is another higher layer protocol built on the same CAN chip that provides all the infrastructure for everything. And allows the communications to occur on the vehicle. And the types of communications that occur, you're really looking at things like, you can read digitally or over the network things like throttle position and transmission information and all kinds of temperatures and those sorts of things. So there's a real benefit to getting that information digitally instead of, having to set up, additional instrumentation to get that information manually.
Right. So the question that that was posed in the previous slide there, so what does that mean? It's one standard across heavy duty vehicles. It's a standardized method of communication. So J1939 provides a common language across manufacturers, but you have to be a little bit careful. Because there are OEM specific tags and things within that protocol.
Yeah, as an example, I just love to jump right in. As an example, one thing you'll find with J1939 is there's a lot of standardized data, a lot of what they call PGNs, which I think we'll talk a little bit more later, that are standardized across kind of multiple manufacturers. However, there's a lot of proprietary information that's only accessible if you happen to know the PGN location, and not all manufacturers share that data. So again, it's a mixture of standardized type data accessible from kind of standard addresses, if you will, along with some proprietary stuff that I think a lot of manufacturers try and hide a little bit.
That's correct.
So let's talk about some application examples.
Yeah, so as we've been talking about here, heavy duty trucks, buses off highway are one of the most well-known applications. There are several other industries where this protocol is used, and forestry, machinery, for example, mining vehicles, military, agriculture, construction, fire and rescue. Now we're transitioning into electric powered vehicles, power generation, even garbage trucks, and we've been involved in applications in all of these.
Yeah, absolutely. And I would jump in here as well and say that at Horner, we've been involved pretty heavily in a lot of these different industries. In our case, primarily because we're one of the few PLCs that actually supports J1939 natively as one of our native CAN protocols. So that gives us an advantage in that area. Another area which we're successful in on our side, on the Horner side of things, is for a lot of these different industries, it's not always on the mobile vehicle itself where we're used. It's often in the test departments whether it's the departments that are testing a new design of a new product or whether they're doing production type testing. So lots of different applications. And you guys have some really cool ones that you're highlighting here a little bit later.
Right. To one of your points there, collecting the data in an R&D situation as well, in research and development, a very important piece of that as well. So, as we were talking about the proprietary messaging with vehicle OEMs, they use their own unique solution at times. The parameter group number, PGN, as Chuck mentioned earlier, is used to proprietize the process data and map it accordingly. Not all parameters are adjustable. Bit rate, TMR, for example, are a couple. Where we come into play here is because of our ability to customize and develop products specifically. We are very strong in working with, whether it's one of our integration partners or directly with the OEM. We can configure these settings, work together to provide these variants that are required with during the design of these products.
Yeah, so you can adapt to any specific, if there's any customized type parameters here, you have the ability to adapt to that. That's really cool. All right, let's talk about some of these awesome applications.
Sure. So what you're seeing here is a salt truck application. In this particular situation, IP 69K is the protection class is important. You have corrosive elements
Salt.
here, salt, right? In some situations, some counties they make you use sand or grit.
Sure.
The temperature range is an important factor here, and also we optimize the mechanical characteristics in this situation. So it was during the assembly of this product, it was easy to implement.
Cool. All right, so that's the salt truck. Now let's move on to road marking. That's a pretty common application.
Correct. And in this particular situation where you see that axial load on the tire in that little lower left-hand corner, there's high axial loads on that bearing. We're able to deal with that. We have variants that can handle up to 400 Newton meters as far as the axial load, and again, while delivering a highly precise signal or resolution up to 25,000 pulses per revolution. Again, because we're in a environmental situation, needs to be taken into consideration. We have broad temperature range. Again, the protection class comes in here. So
sure.
Another
Very cool.
implication. Yep.
Awesome. Okay, cranes.
Right. So you see a couple different things here. The cargo ship crane. Height, position. This in the upper inset of the picture there, we're using an encoder along with a cam switch for that wind turbine there at the top.
Sure.
So a lot of different applications with cranes, and as far as the position, speed, length, height,
all that kind of good stuff.
Right. So again, here a lot of flexibility. Most commonly encoders are known to be mounted on a motor shaft, but we have the mechanical variants that can adapt to several different scenarios.
Cool.
And one thing to keep in mind there, just before we advance real quick, the cargo ships, again, the salt in the air can be very corrosive near the ports. So
absolutely,
protection class is important there.
Cool. All right, yeah, that's good information. I hadn't really thought about that. But of course, anytime you're near the ocean like that or on shipboards and that sort of thing, you're going to have a very corrosive environment. All right, drilling rig.
Right. So here we have an encoder with the draw wire for depth measurement. It's small and compact assembly. It'll give a very precise location of the, not only the angle but the depth. And then here you can experience a high degree of vibration. So vibration and shock resistance
Sure.
is important.
No question. All right, now let's get to what looks like a pretty cool application. What is that thing there on the left? Are we talking like a ski type accessory or what?
Correct. It's a groomer for grooming the ski trails. So you see on the end of that vehicle, there's a crane boom. Our encoder, not only can detect the position of that, but also, for homing, what they call it. Is it safe? Is it back at home, for example? With the inset on the right, the same deal. The rotation of that boom. And then back for safety reasons, is it back at home? Can we proceed with other functions?
Very cool. Yeah, just as a little extra piece of information, I don't think J1939 is involved, but at Horner, we have some really nice applications with snowmaking equipment at ski facilities. So pretty awesome. All right, Tom. Well, thanks for going through J1939 with us, as well as sharing some of the applications. We're going to bring you back one more time before we finish up. Talk to you in a minute.
Thanks, Chuck.
Okay, before we dive into the configuration of the Horner all-in-one controller for talking to the encoder over J1939, let's extract the key pieces of information from the Wachendorff data sheet for the encoder. So I've highlighted pretty much what the important information is. So the way this encoder works is it broadcasts position data every 50 milliseconds by default, and it does so from a J1939 ECU address of A hex, which is 10 decimal, and it's addressed identifying with a PGN of FF00 hex, which is 65,280 decimal. So with those pieces of information, we can head into the Cscape 10 configuration software and configure the Horner all-in-one controller. Okay, so here we go. So this is the Horner Cscape 10 software, which configures every aspect of the application. We're looking at a screen I've created. Now, I have designed this demo for use with the XL7 Prime 7-inch HMI plus PLC. Here's a screen I created, which shows some status information for J1939, along with 3 pieces of information that I'm monitoring over the network. Elsewhere on the network, besides the encoder, there is a engine control module. So I'm monitoring engine RPM and coolant temperature here on the screen. And then I'm also monitoring encoder position as a double integer. And I've created this HMI screen just with this data on there. Okay, now let's take a look at how we configured it so that the data gets into the Horner controller to begin with. And to do that, we go to Hardware Configuration. Okay, and then this is our XL7 Prime controller. And then under Network Ports, the XL7 Prime has 2 CAN ports, and I've configured the second CAN port for J1939. Okay, so I'll hit the Configure button. Now, on the overall network configuration level, the key here is I have configured the baud rate for J1939 on the Horner all-in-one controller as 500K. All right, and I've also enabled what we call extended PGN mode. So all that means is we can map up to 32 pieces of PGN data coming from various peripherals on the J1939 network. Most of the time, most of the data is coming from the engine control module. In this case, we've got some coming from the engine control module and some coming from the encoder. So when I do hit this enabled button here, it details for me, after I have assigned a variable, an array variable, that gives me all kinds of information here. So one of the pieces of array variable data is the status information that I can use to monitor what's happening on communicating over the J1939 network. There's also a bit that I'll need to turn on in this particular word of data here, the lower bit, which basically says, okay, go ahead and start scanning or monitoring J1939 and extract the data for me. And we have a more detailed J1939 video where I go through this in a little more detail. All right, so this is the overall configuration. And then we get to the configuration for the received data that we want to receive in. Now, I showed you on that HMI screen that I have an engine temperature PGN that I'm monitoring. Here's the PGN number. Now, it's coming from the engine controller module, and in almost every case, that is has a source address of 0. And when I'm receiving in data, only the source address really matters. So source address of 0 means it's coming from the engine control module. That's perfect. There's my PGN number. Here's my 8 bytes that are coming in. And where are they coming into? Well, they're coming into a variable that I've assigned and created called PGN 65262. I could have called it anything. I could have called it engine temperature, but I chose to name it what I did. And this is an arrayed variable, a 16-bit type arrayed variable that takes these 8 bytes and copies them into 4 words from array element 0 through array element 3. Okay, so that's where the engine temperature comes in. Here's where the next PGN comes in here. I believe this is RPM data. You can see the PGN number still coming from the engine control module or address 0. It's still 8 bytes, and I've got another variable where that data is copied into. Now down here, there's a choice on all of these PGNs for, are we in monitor mode where the data is just automatically being broadcast and we just pick it off the network without asking for it, or do we have to ask for it? In the case of all 3 of these PGNs, this is just data that's coming automatically on the network. Okay, now we get to the encoder position, which I configured for interfacing with the encoder. Okay, so this is the key information we gleaned from the Wachendorff datasheet. Here's our PGN for the Wachendorff. Now, its source address is not 0. Its source address is a hex or 10. So I filled that in here, okay? And then it's only 5 bytes instead of 8. And I've created a different variable to pull those bytes into a variable array. All right, and that's really all there is to it. And that data is now coming, that encoder position data is coming into these words that are part of this array variable here. And then one more thing I'm going to show you, okay, and that is to get those bytes that are packed into words coming in over J1939 from that variable into a 32-bit variable that I can display here. I'm going to do that through my program variable table. So I'm pulling up my program variable table. I'll scan down through my global variables and get to the bottom here. Okay, so here is the variable, the integer-based variable where I'm pulling in the 5 bytes, okay, but they're being pulled into words, all right, and I want then to copy that data into a single, at least I want to copy the first 4 bytes into a 32-bit double integer variable here. So the way I've done that is I've done that with some direct mapping. So I've mapped the 4 words coming in to a fixed register variable of R1001 through R1004. And then this double integer variable is also mapped starting at R1001. And because it's a double integer, the contents of R1001 and R1002 will be copied into this variable, and that happens to equal those first 4 bytes, which is the position data. So it's a little bit of a trick here to take byte data that's packed into words and copy it over into basically a double integer variable. And the Horner all-in-one controllers effectively have 50,000 available registers, which normally you don't have to worry about. Normally, for variable mapping, that's all just happens in the background, but occasionally if you need to send data out over Modbus or something of that nature, and in this case we're doing a little bit of a mapping trick, then that's another scenario where we use registers for that. Okay, so that's basically all that's involved in getting the data into this variable here, and then to get it on the screen, I have a data object here that I've configured, and you can see I've mapped that variable here as the variable which is the source of the data to display on the screen. It's 32-bit data. It's basically decimal data. It's not signed decimal data because the data is coming in without a sign. I'm using all the digits. There's the size, and then I've assigned a legend that says encoder position. Okay, so that's really all that's involved in displaying the data on the screen. Okay, so that should give you a quick idea of what the capabilities are. Of course, we have dozens and dozens and dozens of videos that can show you how to program the Horner OCS all-in-one controller using Cscape. And hopefully this gives you a good flavor for how you can use the Horner all-in-one controllers over J1939 and with a device like the Wachendorff J1939 Encoder. Okay, so we hope you've gotten a lot of really good information today about J1939 and the Horner PLCs, as well as the Wachendorff encoders. And before we finish here, I want to bring Tom back in one more time. So if you're interested in more information about the products that Tom has presented to us today from Wachendorff, that you'll know where to go next. So let's bring Tom in one last time. All right, Tom, why don't you show us a little bit about how folks can get in touch with Wachendorff? But before then, why don't you just let folks know about some of the other industries in which you are active?
So as Chuck, as you mentioned, aside from J1939, Horner can be involved in many other vertical segments, as are we. So you see a variety of target industries that we operate in.
Yeah, basically anywhere you can use an encoder in an industrial application, you guys are involved pretty much, right?
Yeah, right. So, food and bev, I mentioned elevators, web and converting is an interesting one. They use a length measurement system to, keep track of the spooling of that flat material. Industrial robots, AMRs, AGVs,
sure,
for the steering. Renewable energy, I showed an example where we had an encoder on a cam switch. Also, the pitch and the yaw of the blades.
Sure.
Industrial plants. There's many on conveyors, for example, the distance that things travel, the
Sure.
speed that things travel. Marking systems, also, you can see down at the left-hand corner there, they use encoders for that application on commercial industrial marking systems, jet bridges. So we're involved in quite a few different industry segments.
Awesome. So, okay, just to finish up then, let's go ahead and let people know where you're located and how to get in touch with you.
Sure. I'm in Chicago, Illinois. And again, I'm part of the Wachendorff Automation USA Inc. team. Again, we have a worldwide network of distributors and have applications installed, customer solutions worldwide. And Chuck, in the next slide, I'm going to introduce some of my team members. Christoph and Leon help me out
at the Chicago office there, or in the Americas, or
they're based at the headquarters in Geisenheim, but frequently come and travel with me in the U.S. And
so they're really focused on the U.S. a lot, along with you.
Correct. Yes. And if you advance the slide, these are some of my other team members internally at the headquarters. Great colleagues, very high level of knowledge, a lot of tenure in the industry, and they're all very willing to share their knowledge and help. So here is my contact information on the left, my email, my phone number. I'd be happy to talk to any of you and help with your application. And if you needed to contact my team, off to the right, there are some emails there where you can also get in contact with them. And, also feel free to visit our website, Wachendorff.com. There you can find a configurator if you need to try to cross over an encoder that you have. Also, there's a plethora of knowledge-based articles and applications. We also have a variety of different protocols that we're involved with: Ethernet IP, Profinet, CAN Open, and then the serial interfaces as well.
Sure.
A lot of different mechanical interfaces. We can really address a lot of different things. So feel free to check out our website. It's easy to use. There's some great information on there.
Awesome. Well, I want to thank you again, Tom, for joining us today. And I look forward to working with you in the future.
Thanks, Chuck. It was really great that you invited me to be on here. I enjoyed it, and thank you very much. And look forward to working with you guys as well.
All
Thank
right.
you.
All right. Take care. Okay, this is where I remind you that we're here every Tuesday at 2 o'clock. And if you want to watch us live, we'll have somebody standing by. Just give us those comments and questions in the chat section. If you watch on replay, we'd love to see your comments and questions in the comment section, and we'll get back to you very quickly on those. I want to announce that we will be releasing our 2025 training schedule for our OCS all-in-one controller, so keep checking back on our website for the specific dates that will be announced soon. Lots of ways to interact with Horner online at our website at hornerautomation.com, on our YouTube channel where you'll find this and hundreds of videos, as well as on LinkedIn. Next week, we're going to talk about IEC 61131 logic programming in Cscape 10. And we have a real proponent of IEC that is going to be my special guest, a colleague of mine that I've worked with for, probably 20 years. And he's going to explain why IEC is a great choice for your next application using a Horner all-in-one controller and Cscape 10. If you haven't done so already, don't hesitate to subscribe to our channel. It doesn't cost anything. And if you choose to subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week when we talk IEC and Cscape 10, let's all get out there and do us some good.